Geometric sequences. Our objective is to recognize and extend geometric sequences, as well as find the nth term of a geometric sequence. Who uses this? Bungee jumpers can use geometric sequences to calculate how high they will bounce. So let's look at extending geometric sequences. So we want to find the next three terms in each geometric sequence. So if we look at this first one here, to go from 1 to 3, we multiply by 3. And then from 3 to 9, we multiply by 3. And then from 9 to 27, we multiply by 3. So our next three terms, we're simply going to multiply by 3. So 27 times 3 is going to give us 81. And then 81 times 3 gives us 243. And then we take 243, multiply that by 3, and we get 729. Now let's look at this next one. In a geometric sequence, you're multiplying. So if we look here, we're going from a negative to a positive to a negative to a positive. That means your ratio is going to be a negative number. Because a negative times a negative is a positive, but when you do a positive times a negative, you're going to end up with a negative. So what do you do to go from negative 16 to 4? Well, you divided by negative 4. Well, dividing by negative 4 is the same thing as multiplying by negative 1/4. If you're having trouble figuring out what the common ratio is, you can always take the second term and divide it by the first. For example, 4 divided by negative 16, and that reduces to negative 1/4. And that will always give you your common ratio as a multiplication problem. So now we want to take our 1/4, and we're going to multiply that by negative 1/4. So 1/4 times negative 1/4 is going to leave us with negative 1/16. And now we're going to multiply this by negative 1/4. And that's going to give us a positive, since a negative times a negative is a positive. So we're going to have a positive 1 over, and then 16 times 4 is 64. And our next one, we're going to take our 1/64, and we're going to multiply that by negative 1/4. So a positive times a negative is a negative. 1 times 1 is 1. And then 64 times 4 is 256. So those are the next three terms in that sequence. Sometimes you're trying to find a term that's not like one of the next couple. So to do this, you're going to need to know this formula. If the first term of a geometric sequence is a sub 1, the nth term is a sub n, and the common ratio is r. So when you're using these letters, this is going to be the formula we use for a geometric sequence. So we have a sub n is representing what is the nth term, what is that term we're looking for. And then we have our first term, so we have a sub 1, the first term in the sequence, and we have our common ratio. What do we keep multiplying by? And then we have n minus 1. So let's take a moment and try to look at the numbers that we have up here. We have 3, 6, 12, and 24. So say we want to find what the 8th term is. You can probably go through and multiply by the common ratio until you get to the 8th term. But we're going to practice using this formula. So our first term is 3. So we have a 3. What is our common ratio? What do we keep multiplying by? Well, to go from 3 to 6, we multiply by 2. From 6 to 12, we multiplied that by 2. And from 12 to 24, we multiplied by 2. So our common ratio is 2. Now we deal with the term we're looking for. In this case, we're looking for the 8th term. They'll tell you which term you're looking for. So we end up with a sub 8 equals 3 times 2 to the 8 minus 1. Following order of operations, we want to simplify this 8 minus 1 first, because there is an assumed set of parentheses around it. So now we have 3 times 2 to the 7th. So 2 to the 7th, as we would do exponents first before we multiply, is 128. And now we do 3 times 128, which gives us 384. So that's how you use this formula. Let's take a moment and practice. So let's do this first one together. The first term of a geometric sequence is 128. The common ratio is 0.5. What is the 10th term of the sequence? So we're looking for the 10th term. And our first term, our a sub 1, is 128. Our common ratio is 0.5. And then our exponent is the term that we're looking for, minus 1. And when we simplify, we end up with 0.25. Take a moment and pause the video and try B and C on your own. When you return to the video, the answer for both will be revealed. So for B, it was very similar to A. We took our first term, we placed it in our a sub 1 place, and then we substituted 3 in for r, 5 in for n, and then we simplified. So we did 3 to the 4th, and then multiplied by 8 to get 648. C was a little bit trickier. They gave us the term we were looking for, and they gave us a sequence of numbers. So we had to look at it and notice that 8 was our first term, and then we needed to find the common ratio. So each time it kept multiplying by -2. So the common ratio was -2. So we take 8 times the quantity -2 to the 13 minus 1. And we take our -2 and put that to 12, which gave us 4,096. Now we multiply that by 8 to get our grand total of 32,768. So that's the 13th term in this geometric sequence. Now let's take a moment and look at a sports application. A bungee jumper jumps from a bridge. The diagram shows the bungee jumper's height above the ground at the top of each bounce. The heights form a geometric sequence. What is the bungee jumper's height at the top of the 5th bounce? So we can look at our numbers. So our first one was 200, then our next one was 80, and then our next one was 32, and we want the 5th bounce here. So what's the common ratio? To find our common ratio, we can simply take our second term and divide it by our first. And when we do, we end up with 0.4. So now we have our r value, we have our n value, and we have our a sub 1. So let's fill it in. So we have a sub 5 equals 200, that's our starting point, times 0.4 to the 5 minus 1. And when we simplify, we end up with 5.12. So the height of the 5th bounce is 5.12 feet. And that ends our lesson on geometric sequences.